Have you ever stopped to think about how your Mac in California can send an email to a Windows PC in, say, Tokyo? It feels like magic, right? But it's not. It's all thanks to a set of rules, this kind of invisible language that all our devices have agreed to speak. So today, let's unpack this amazing framework that makes our whole connected world possible, the OSI model. First up, to really get why the OSI model is so important, you got to imagine a world without it. Picture the early days of networking. It was total chaos, a digital Wild West, where every single company had its own proprietary way of doing things. I mean, that's the billion-dollar question, isn't it? Without a common standard, an IBM computer just couldn't reliably talk to an Apple computer. It was a complete mess. And this problem, how do we get all this different gear on the same page, is what sparked one of the most brilliant solutions in all of modern technology. And that solution, of course, is the OSI model. Now, this isn't a piece of hardware or software. It's a conceptual framework. You can think of it as a universal blueprint that finally brought some much-needed order to the chaos of network communication. The best way to picture it is like a 7-story building. Every single piece of data that travels across a network has to take the elevator, stopping at each floor. And every floor has a very, very specific job to do. This layered approach, well, that's the secret to its power. And look, this isn't just some theory you'd find in a dusty textbook. The model has super practical goals. It's all about making sure different technologies can actually play nice together, making it way easier for engineers to figure out what's wrong when things break, and, this is a big one, allowing new tech to be developed for one layer without having to rebuild the entire system from scratch. And here they are, the magnificent 7 layers. This table is basically our roadmap for the rest of this explainer. We're going to follow a single piece of data on its incredible journey, starting all the way up at the top at the application layer, moving down to the physical layer, and then, you guessed it, all the way back up again. All right, let's do something real. Let's send an email. The second you hit that send button, the journey kicks off. Your data is about to travel down through these 7 layers, getting all dressed up and ready for its big trip across the internet. So, this is the path it's going to take, from top to bottom. We're going to focus on a few of the most important steps in this journey, where something new gets added to our data. This whole process has a special name, and it's really the secret sauce to how this all works. That name is encapsulation. Yeah, I know, it sounds a little technical, but the idea is simple. Just think of it like you're preparing a package for international shipping. As the package goes down the line, each layer adds its own wrapper or label with special instructions for its counterpart over at the destination. Okay, so our journey begins right here, at the layer that's closest to you, the user. You type your email, you hit send. Your email program, the application, hands that raw data off to the layers waiting below. Now, after leaving the application, the data zips through the presentation and session layers. They handle stuff like encryption and managing the conversation. Then, bam! It hits a super important floor, the transport layer. If your email is a bit long, this layer chops it up into smaller, numbered chunks called segments. Then it slaps a TCP header on each one to make sure all those pieces arrive safely and can be put back together in the exact right order.
So the whole point of the transport layer is reliability. That TCP header is basically the tracking number you get with certified mail. It guarantees that your package is going to be delivered, and it makes sure nothing gets lost on the way. So our data packet has its tracking number. Now it needs a mailing address. That's the job of the network layer. It adds the IP header, which has the source and destination IP addresses, the logical addresses for computers on the internet. You can think of that IP header as the big, clear address label you write on the front of the box. It's what tells the global postal service, in this case, the internet's routers, exactly where in the world this package needs to go. At last, after its long journey down the building, the fully wrapped data hits the physical layer. This is where all that digital information gets converted into actual physical signals. We're talking electrical pulses zipping through a copper wire, flashes of light in a fiber optic cable, or radio waves for your Wi-Fi. It's ready to travel. And it's off. Our package has been sent. But hey, the journey is only halfway done. Now, on the receiving computer, that entire process we just saw happens again, but completely in reverse. So let's jump over to the receiver's side. Those bits of light or electricity arrive at the physical layer and start their climb up that 7-story building, getting unwrapped one floor at a time. And this reverse process has its own fancy name, decapsulation. As the data moves up, each layer carefully reads and strips off its own header, the one that was put on by its counterpart on the sender's machine. It follows the instructions and passes the rest of the package up to the next layer, until finally your original email data is delivered perfectly intact to the recipient's inbox. Okay, so we followed the journey down the stack and back up. But the real genius of the OSI model isn't just that vertical flow of data. It's the horizontal logic that makes the whole thing work so beautifully. This right here is the magic trick. Even though the data physically has to travel all the way down and all the way back up, each layer is designed to communicate as if it's talking directly to the same exact layer on the other machine. It's called peer-to-peer communication. So here's what that actually means. The TCP header that was added by layer 4 on the sending computer, it is only meant to be read by layer 4 on the receiving computer. The network layer below it couldn't care less about the transport layer's header, and vice versa. This separation of jobs is what makes the whole system so incredibly robust and flexible. And really, that's the ultimate takeaway here. This modular design means you can go out and invent some brand new, amazing Wi-Fi technology at the physical layer. And as long as it does its job correctly, the application layer with your web browser doesn't have to change one single bit. It's what allows the internet to constantly evolve without completely breaking apart. So every single time you send an email, load a web page, or stream a show, this incredible 7-layer conversation is happening billions of times a second all around the globe. It's this beautiful, invisible architecture of agreement. And it really makes you wonder what other elegant systems are out there, quietly making our modern world possible, hiding right in plain sight.